Very good morning, my dear students. Today we'll continue the chapter called Work, Energy and Power. Let us quick recap the basics what we had learned in the last class. Then we will be moving into the next topics today itself. Let's start. So what is our discussion today is work, energy and power. Continuation. Here in this continuation, what is the topic we are starting now is factors on which work done by a force depends, and types of work done. Types of work done. So this is the first topic of today's discussion, whereas these topics we had already discussed in the last class. Let us discuss in some more detailed way. Let's start the first. Factors on which the work done by a force depends. We have the formula. Before going to the formula, let me draw a basic diagram here. This is the ground. This is the ground on which there is a body of mass m is placed. On this mass, a force F is acting. Because of this constant force, this F is constant, remember. Because of this constant force, constant acceleration will be produced by the body. When there is a constant acceleration, the body will be speeding up. As it is speeding up, it will cover some displacement. This is the same body. The displacement covered from initial position to the final position is S. So work done by this force, I am talking about this external force. Work done by this external force is equal to F S cos theta. I hope you could recollect the formula. W is equal to F S cos theta. Now, what is F, what is S, what is cos theta? You know already, but let us discuss once again. So what is this F here? Look at here. F is, carefully see, F is the force acting on the body. S is the displacement taken by the body. Displacement taken by the body. Cos theta. Here, the theta is the angle between F and S. The angle between F and S. What is F? Force. S, displacement. Clear? So the work done by the force is depending on three physical quantities or three parameters. Number one, force acting on the body. That may be acting in the direction of displacement or in the opposite direction of displacement. And number two, the work done by the force is depending on displacement. Then theta. Theta is the most important concept here. That's the reason in the last class we had spent most of the session based on the trigonometry, the basics of trigonometry. That means on the theta values. Right? I hope you remember that. Now, let's see. Let us talk about one by one. Force. When there is no force, there is no work done. When there is no displacement, there is no work done. When there is an angle between F and S is 90 degrees. Substitute 90 here. Cos 90 is 0. Work will be 0. What I am telling you now is work done by the force will be 0 when force is 0, displacement is 0, or theta value is 90. Any one condition is there then work done by the force will be 0. Again, I'm writing here, carefully look at the situation. Work done by the force is 0 joule. SI unit of work done is what? Joule. So when it is possible? So this is possible when F is equal to 0 or S is equal to 0, displacement is 0, or theta value is 90 degrees. In all these three cases, work done by the force will be 0. It doesn't mean that work done by the force to be 0, these all three together must be 0. No. There are three quantities here, F, S and theta. Even one quantity is 0, then the complete work done by the force will be 0, because there is a multiplication is available among all the physical quantities. There is no addition or subtraction here. There is multiplication, F into S into cos theta. If one quantity is 0, the total work done by the force will be 0. Right? Are you understanding? So this is the concept what I am going to tell you now. Right? Let's start. Concentrate on this force. Look at the situation here. So there is a ground, a body of mass m is placed on the ground. I am not applying any force on it. External force I am talking about. What is this external force here? Any body in the nature, the first force acting on it is its weight, mg. If only weight is acting, this body will move down into the ground. Is it happening so? Think about it. If you place a body on the table, will it move into the table? No, right? Because the body is at rest, we say. That means the body is under the action of balancing forces. The first force acting on any body is weight, mg. So to balance this force, there is another force called a normal reaction force. What is that? Normal reaction force. That's what reaction force, right? So let me write. So what is this N here? N is the reaction force. In the last class, I had mentioned about this. So this is not our discussion. Our discussion is what? Our discussion is I am not applying any external force on the body. Then what is the work done by the force here? Work done by the force is 0 because F into S into cos theta, F is 0, then complete product will be 0. So work done by this force will be 0 because there is no force here. When there is no force, is there any displacement? Tell me. When there is no force, is there any displacement? In this case I am talking about. No, impossible. Clear? When there is no force, there is no displacement. So I am writing here displacement is 0. A very interesting case I am going to tell you now. A very interesting case. Let's see. So this is the ground. This is the ground. There is a wall here. Look at here. It's a wall. A strong wall. A man here pushing this wall with a force, a great force. 1000 newtons, 2000 newtons, 5000 newtons. He is constantly trying to push the wall. Imagine this is the wall. I am constantly trying to push the wall. See here. Imagine if I am doing the same exercise for hours together. What happens? Will I be able to move this wall? Think carefully. If I am doing the constant force application for hours together, what happens? Will I be able to move this wall? Impossible, right? Whereas I am applying force. So in this case, force is there. F is not equal to 0. Not equal to 0 means some value I am applying on the wall. But what happened finally? The displacement is 0. Displacement is 0 meters for the wall. Wall is the object here. I am applying force on the object, but there is no displacement. In this case also, work done by the force is 0 joules. Work done by this force is 0 joules. But you may think that, why work done is 0 here? Whereas, I am doing lot of work done. That's called a physical work, not physics work. There is a lot of difference between physical work and physics work. in physics, according to the physics, science, work done by the force is equal to force into displacement into cos theta. There is no displacement, there is no work done, but you get sweat. That's due to the physical activity and internal muscular activity. That is not the work done by the force. I told you, work done you should not say. At any point of time, you should never say that according to the physics I'm talking about. You should never say that work done. What you should say then? Work done by a force. What force? That may be any force. The last class we had discussed. Work done by the force, you should say. That force may be frictional force, maybe external force, maybe gravitational force, maybe centripetal force. Clear? Right. Now, one more case, let me tell you. One more case. So this is the case we had already discussed in the last class. Last class we had already discussed. I am applying a force in this direction. Now there is a displacement taken by the body. So this is the displacement S, and see, interestingly, the reaction force acting on the body is in this direction. Alright? Here force is there, displacement is there, but interesting thing is theta. Theta is angle between force and displacement. I am going to find work done by the normal force. Look at here, work done by normal force. Work done by normal force. So what is the normal force? N into, what is the displacement? S into, what is cos angle? Cos theta. What is theta here? Force into displacement. See, force and displacement, the angle between them. This is the force and this is the displacement. This is the force and displacement. The angle between them is how much? So it's cos 90 degrees, and cos 90 is how much? 0. So finally, work done by the normal reaction force is 0. Got it? It's just because theta is 90 degrees. You understand the concept? Really? This is the concept. What factors affecting on the work done by the force? One more thing. Let's take this example here. This is the ground. So there is a man standing on the ground by keeping 100 kg object on his head. 100 kg object. 100 kg means 1000 newtons force is acting on him. He is just standing. He is just standing. Some 2 hours he is standing still. From 2 hours, what happens? He feels that a lot of physical activity he is doing. He is just holding it. Lot of physical activity. But according to the physics, he is just standing. That's it. There is no displacement taken by the body. So as the displacement taken by the body is 0, so the work done by him also will be 0 according to the physics. Clear? Now, one more important point I am going to tell you. Carefully see. I am going to concentrate on theta 90 degrees case here. Theta 90 degrees case. A very important concept which is helpful for your NEET, JEE, CET exams. Commonly asked question from this chapter. Let's see this. It's called an application here. Application here. In case of whirling of a stone. In case of whirling of a stone. What is meant by whirling of a stone? Imagine I have a thread. One end of the thread, I'm just holding it. Another end of the thread is connected or tied to a stone. Right? Like this. Look at here. So this is one end of the stone. This is the, one end of the rope. And another end of the rope is tied to a stone of mass M. What happens in this case? Whirling of a stone. I'm just holding at one end and whirling like that. It's called whirling. It's rotating. Right? So if you carefully observe that, I'm rotating like this. So this is the point, is called the center now. Yes or no? So the center of this is like this. I'm just holding it and rotating. It's a center. About the center, the stone is rotating. Right? So stone is rotating in a circular path about the center. Look at here. Understand? Any body to move in a circular path, there is a force necessary. Any body to move in a circular path, there is a force necessary. What is that force? Could you recollect from your basics? What is that force? So that force is called a centripetal force. Look at here. What is that force called? A centripetal force. Centripetal force is necessary for any body to move in a circular path. For example, take a bicycle which is making a turn in a circular track. There is a centripetal force is necessary there. Imagine a situation where a planet is revolving around the sun. There is a centripetal force is required. Anybody in this case also. Look at here. That centripetal force is always acting towards the center of the circular path. If it is a circular path, see this, towards the center only the centripetal force will act. Imagine this mass is here, mass m, so you know this is the string, and towards the center of the circular path the centripetal force will act. So that's a centripetal force here I am considering as capital F. Alright, clear? Now the question is, what is the work done by the centripetal force? We understand the concept. What is the work done by the centripetal force? Remember, work done by the centripetal force will always be zero. Remember, work done by the centripetal force is always zero, because work done by the centripetal force, whatever may be the force, the formula will be Fs cos theta. F into S into cos theta. Work done by the centripetal force is equal to F. What is this? This is F, centripetal force, into S. What is S here? S is the vector quantity, it's a displacement. In a circular path, remember, in a circular path, at any point if you want to find a vector quantity, that may be acceleration, that may be a velocity, that may be the displacement. Remember, these three are vector quantities, yes or no? Acceleration, writing once again, acceleration, displacement, velocity, these are the vector quantities. If you want to find the direction of the vector quantity in a circular path, at this point, you need to draw a tangent. Look at here. At any point, if you want to find the direction of any vector quantity in a circular path, you need to draw a tangent. You know how to draw the tangent, right? Yes. Imagine a situation, the stone has come here because we are whirling it. At this instant, so this is the centripetal force direction towards the center, and this is the displacement you can see here. At any instant you see what is the angle between force and displacement? Tell me, what is the angle between force and displacement at any instant? At this instant, force is in this direction, displacement is in this direction. Look at here, it is 90 degrees, yes or no? At this instant you see this is force direction and this is displacement direction. Look at here, it's 90 degrees. At this instant also you can see it's a force direction and it is displacement direction. It's 90 degrees. Is it clear? Cos 90 is how much? Just substitute yes into cos 90 degrees. What is cos 90 degrees here? So W, work done by the centripetal force, as it is 0, so it's a 0 source. Clear? And again I am telling you, the same concept is applicable for the topic called work done by the gravitational force when a planet is revolving around the sun. Right? Look at here. Imagine, this is the sun. Same situation, it's a sun. This is the planet. Here, planet is revolving around the sun in the circular path. In reality, it is moving in elliptical path. In gravitation chapter, I have told you clearly. While solving the numericals and understanding the concept, if you consider the planets are revolving around the sun in a circular path, then it will be very easy for us. But if you consider exactly the ellipse, a lot of mathematical difficulties will arise to derive or to deduce a relationship. Clear? Understand? So let us imagine that the planet is revolving in a circular path. What happens in this case? Same situation. Work done by the centripetal force will be 0, but here the centripetal force is equal to the gravitational force between them. Remember, the gravitational force between them. The centripetal force is equal to what? Gravitational force between the planet and the sun. So that's the reason I told work done by the gravitational force is equal to 0. Where? In which case? In the case where the planet is revolving around the sun. Whereas in this application called whirling of a stone, work done by the centripetal force will be 0. Clear? Now let us discuss about the types of work done. Now, so my dear students, let's continue. Look at here. Case 1. This is the case 1. So ground. There is a body is placed here. Displacement is in this direction. Force acting on this body is in this direction. Our consideration of force is in this direction. In this case, work done by the force is 0. So that's called 0 work done. Yes or no? What is that called? 0 work done. Clear? Now, another case let's take. It's case 2 here. This is the ground. Why it is 0? Because theta is 90 degrees here. Cos 90 will be 0. In this case, this is the body. Displacement I am just taking in the same direction in every case. But the force direction I am changing. Here, the force is acting in the direction of displacement. And we know already W is equal to F into S into cos 0 degrees. Clear? What is cos 0 degrees here? Cos 0 is 1. So F into S. The force is F into S, and this is called a positive work done. What is it called? A positive work done. Clear? Now, case 3, let me take case 3. It's case 3 here. Let me draw the diagram. So this is what? The ground, what I have considered. Here, this is the body. The displacement direction, as I've told you, along the same direction I'm taking. Now, the force direction is opposite to the displacement. In this case, work done by this force is equal to F into S into cos. What is the angle between these two directions? Exactly, they're opposite each other. What's the angle between them? It's 180 degrees. What is cos 180 degrees? So W is equal to F into S into minus 1, and it's called minus F into S. That's called a negative work done. What is it called? Negative work done. I hope it's very clear for you based on types of work done. There are 3 types of work done: positive work done, negative work done, and 0 work done. Is it clear? Clear for everyone? Now, a lot of examples we have discussed in the last slides even, right? Ready? Now, let's check here. What I'm going to conclude about the types of work done is W is equal to Fs cos theta. Depends on the theta value. You get maximum work done or minimum work done. Clear? So, when the theta value is 0 degrees, you get W is equal to F into S. When theta value is 90 degrees, you get W is equal to 0. And if the theta value is 180 degrees, you get W is equal to minus force into displacement. Right? And this is the value called a maximum work done. Yes or no? Positive value, F into S. So this is the 0. and this is the work done, we get it as the minimum work done by the force. Maximum work done by the force when force and displacements are in same direction. Zero work done you get when force and displacement are in perpendicular to each other. And the minimum work done you get when force and displacements are in opposite direction. Is it clear? Everyone, remember that. It's a conclusion about types of work done. Now, the major concepts for today is factors on which the work done by the force depends and types of work done is done. Now, commonly asked questions will be simple. We know work done by the force W is equal to Fs cos theta. So they will give F value is 100 newtons. For example, I give S value is some 50 meters. And theta they had mentioned about 60 degrees. The question is find out the work done by the force. Work done by the force is equal to F 100 into displacement 50 into theta is 60. Cos 60 is how much? It's 1 by 2, right? So this is 225. So work done by the force will be 2500 joule. SI unit of work done is what? Joule. And work done by the force is a scalar quantity or a vector quantity? Work done by the force is a scalar quantity. Do not consider the force. Work done is a physical quantity or work is a physical quantity. See here, work is a physical quantity which is a scalar. Energy is a scalar and the power is a scalar. Like this commonly asked question. For example, sometimes they will not give cost. They'll ask you to find theta value by giving work, force, displacement. In that way, vice versa. That way questions can be asked. Alright? Now, look at one more important and interesting question of the chapter. There is a truck. Look at here. There is a truck of mass 5000 kg. This is traveling with some initial velocity, I can say 40 meters per second. Initial velocity. And it got stopped due to the brakes applied. See here, it got stopped due to the brakes applied after traveling a distance called 100 meters. Careful listen. Brakes are applied after traveling 100 meters distance. It is stopped. Stopped means I can write final velocity is 0 meters per second. You know the question? The question is the combination of Newton's laws of motion and work done by the force. Like this. Combination of questions will be asked in JEE kind of exams especially. The question is, what is the braking force applied on it? And what is that work done by the force? Are you ready? Braking force, it's so simple. Whatever may be the force, it's mass into acceleration. Mass is clearly given 5000 kg and acceleration you can find by using initial velocity and final velocity. Finally about displacement also they gave. We have equations of motion. What are the equations of motion we have? V is equal to u plus at. S is equal to ut plus half at square, and v square minus u square is equal to 2as. What is the equation I can use here? Can I use first equation? No. Why? Because time is not at all mentioned here. Why? See, I'm just starting and explaining from the basic level because there are some new joining students are there. So that's the reason. From the basics again we are discussing. So second equation can I use? No, because time is included in this equation even. Can I use the third equation? 100% you're right, you can use the third equation. From this, what I can write? F is equal to m into, what is this A? This A will be v square minus u square by 2a. We substitute everything. F is equal to M. What is M? 5000 into. What is V square? V square is 0 square minus. What is U square? U square is 40 whole square. So divided by 2 into A. Clear? Now, so if you take this is the part, right? Sorry, 2s, sorry. V square minus U square by 2s. This is, sorry. See, from here, A is equal to V square minus U square by 2s. So this s also is given 100. Concentrate on this part. So your F is equal to 5000 into 0 square, it's 0, minus 40 square, it's 1600 divided by 200. Clear? So this is 0 minus. Now, carefully see. Here, this can also be written as 5000 into minus 1600 by 200. So 2 zeros, and this is 2 8s. So 5 8 is 40, right? So the answer is minus 40,000 Newton. See here, 5 into 8, 40 and 3 zeros. 3 zeros are there. 40, 3 zeros. Minus 40,000 Newton is the braking force. Minus indicates force is acting in the opposite direction of displacement. So then only the braking force you can consider that. F is equal to how much? Minus 40,000 Newtons. So we got the force. And what is the work done by the force? It's so simple. Work done by the force is W is equal to F into displacement. Understand? So F is how much? Minus 40,000 into displacement is 100. Okay. So why we are not considering cos theta here? Because if you take cos theta, what happens? Cos theta value will be 180. Cos 180 will be minus 1. Minus already you have got here. Clear? So that's the reason we are not taking cos theta. So we are just writing F into S. F is minus 40,000 into 100. How much completely? It's minus 4 into, how many zeros are there? 1, 2, 3, 4, 5, 6. So minus 4 into 10 raised to 6 joules. Is it clear? So this is how the numericals will be asked on the combination of force and loss of motion and work, energy and power. So let's discuss one more numerical, the last numerical for the session today. So my dear students, look at here. The question what we are going to discuss is also an application and continuation of the chapter. And this is the application was asked many times in PUC board exams. And this is equally important for your NEET exam even. Let's see that application. It's a very simple and conceptual application. Question is, there is a body of mass m which is at rest initially. Which is at rest. U is 0. After applying a force, I can say it's a constant force. After some time, its velocity has become v. They have never mentioned, they have nothing mentioned about the displacement. They have not mentioned about the displacement at all. Clear? You understand the question? Simple. There is a body which is at rest. After applying a constant force, its velocity becomes v at that particular instant. The question is, what is the work done by a force? No displacement, but initial velocity and final velocity we have. We need to find the work done by the force in terms of, look at here, in terms of u and v, because only this data is given. So interesting. Let's start. The basic concept is work done by the force is equal to F into S into cos theta. Here F into S, because cos theta is what? Theta value will be 0 because force is in this direction, the body is moving in this direction. S cos 0 degrees. Cos 0 degrees is 1. That's why I wrote F into S. When here again we know the equations of motion, v square minus u square is equal to 2as. We don't know about the displacement, right? That's why displacement I can write in terms of v square and u square. See, displacement is equal to v square minus u square by 2a. Alright, see here. So W is equal to F into S is v square minus u square by 2a. Clear? Now, we don't know about acceleration even, but we know about the mass. They mentioned about the mass. So this F I can write in terms of mass into acceleration into v square minus u square by 2a. What happens here? A cancels. Now, what is the data you have? Data you have m, v and u. M, v, u. 2 is anyway constant. The final answer, work done by the force is equal to half m v square. This is right, minus half m u square. Okay, half m v square minus half m u square. As u is equal to 0, and what is that? When u, if you substitute 0, so this complete term will become 0 and you get work done by this force, constant force will be half mv square. Is that half mv square is the kinetic energy of the body? What is the formula for kinetic energy? From the lower classes onwards, you might be studying the same. Kinetic energy is half mv square, potential energy is mgh. Right? So next topic is about energy. This is about the work done. So 2 sessions completely we have dedicated for work done by the force. Once your first PUC begins, and we need to spend more time for this work done by the force, because here only constant force we discussed. When you start your first PUC topics, there will be work done by a variable force also will exist. Clear? See here, we have started with the work and we have ended up with energy, which is the kinetic energy. What is this energy? We will discuss in the next session.